Hello everyone, welcome to lecture 3 of Introduction to CFD. This time around we're still going to be using the software hands-on, but now instead of using the quick setup mode that we used last time, we're going to use the general mode, which is basically the one that you use when you're dealing with more complex problems. And also we're going to use a more refined mesh in this lecture. To highlight the differences between a coarser mesh and a more refined one, we're gonna do the same problem that we did the last lecture. So we're gonna have our static mixer right here. We're gonna have water entering at 2 meters per second at 315 Kelvin. And on the right, we're gonna have water entering at the same rate, but at 285 Kelvin. So the basic difference is going to be that we're going to use the general mode and we're going to use a more refined mesh. So I can highlight a little bit better the difference between the difference in results that you get. Okay? So let's begin. We're gonna be using CFX, so if you don't remember, just type the Windows key, type CFX and choose CFX 2020 R2. Okay, there you go. Now, you're gonna remember that you're gonna have to select your working directory. Okay, so I'm gonna send you this file right here. Let me show you. You're gonna have this, okay? I'm gonna send you guys this file through email. So you will want to extract the files here. You can extract in any folder. Just remember the folder that you extracted it to, so that you can choose it to be your working directory. So you can do this, like go to your Windows Explorer in the folder that you have this, extract the files, click here, copy this entire directory right here, and you can just put it here and paste it, okay? Or you can just go, let's say you are in your computer, you can find your file. Mine is here into CFD and it's going to be this one, so I choose this one, so I have my working directory set properly. Okay, and this is important because when you want to open files and you click to open files inside CFX, the software is already going to show you the folder that the software is going to open the working directory folder. So it's better to have all your files in there already. Okay, so you click CFX Pre right here. Okay, and you click new case here, or file, new case, or Control N, and this is the first main difference. Remember that in our previous lecture we used quick setup. Now we're going to use the general setup. Okay, this is gonna give us a lot more options to choose from when setting up the conditions. We're not gonna go too much in deep into them, but I do want to show you that those options are there, and you have much more options than you had when we were dealing with quick setup. Okay, so let's go. There you go. Now we have this blank canvas here, and what we're gonna do is we're gonna import our mesh. This time it's gonna be a more refined mesh, so make sure that the mesh file is this one, static mixer ref mesh. Just to show you, this is the mesh that we used before, static mixer mesh. Now we're gonna be using the refined one. So make sure that you're opening the static mixer ref mesh, because sometimes the software loads the working directory that you chose before. So maybe you're gonna click here to import the mesh. It's gonna open the previous working directory and you're gonna be selecting the wrong file. Okay, so make sure the name is static mixer ref mesh.dtm. Okay, and open it. There you go. Right now, you don't see any difference because you're not, what you see here is not the mesh. What you see there is the general geometry, okay? There you go. So now, what we want to do is set up our previous conditions. Our boundary conditions, sorry. So they're the same as the ones from lecture 2, not tutorial, lecture 2, okay? So this is how we're gonna set it up. First, we're gonna set up the inlet condition. Remember when in the previous lecture we set up the inlet, the outlet, two inlets actually and one outlet. So this is what we're gonna do here. But first, we want to check if our default domain has the options that we want. So double click default domain. This is the first thing that we're gonna change. We're not dealing with air at 25 Celsius, we're dealing with water, okay? If water is not showing up in the tree, just click the ellipsis, go expand water data and choose water, okay? Make sure that our reference pressure is set to 1 atm, okay? Then click here, fluid models, and change from isothermal to thermal energy, okay? And also make sure that our turbulence model is set to chi epsilon, okay? You can already see that we have much more options when we are dealing with this part of the lecture than we had in the quick setup, okay? So this is to highlight to you guys how many more options we have when we are working with the general setup instead of the quick setup, okay? So we have the domain set up properly. Before we continue, let's save our case. So I'm gonna open up here. I'm gonna save it as lecture. Oh my God, lecture 3. Okay. There you go. Now we're gonna define our boundary conditions. We can either click here in boundary, or we can go insert boundary. Okay. And remember, if we choose the correct name, the software is already going to choose to us the correct face. Okay, so I'm going to choose in 1. There you go. Because I chose the name to be in 1, the location is already set up properly. Okay, just so you guys remember, let's say I chose to name it inlet 1. Now the location is not set up automatically, so I have to go here and select in 1. Okay, so make sure that the inlet boundary name is set up properly. Okay, this is something that you would have in mind if we had done the mesh process, because in the mesh process is where we establish the name of these faces that we're going to be using as boundary conditions here. Okay, but since we're skipping the meshing process, we're going to be using the ones that already are predetermined. Okay, so make sure the location is in 1, make sure the boundary type is inlet, and go to boundary details. Okay, now we're going to set up the speed at which the water enters our domain, which is 2 meters per second. Make sure the unit is correct, and the temperature is 315 Kelvin. Okay, so 315, make sure that the unit is correct and click apply. So now you already have your first boundary condition set up, and you can see that it is represented by black arrows pointed inwards the domain, so we know this is a boundary, this is an inlet boundary condition. Okay, we'll click OK. Now we're going to set up our second inlet. Again, the boundary conditions are the same as lecture 2, because in this lecture I want you to get familiarized with the general setup and showcase the differences between a coarser mesh and a more refined one, okay? So another way to insert a boundary condition is that you can go here in the default domain, right click it, go to insert boundary, okay? And then we're gonna type in 2, and there we go. The correct boundary is already selected to us, okay? So go to boundary details, the speed is the same, and the temperature, but the temperature is different. The temperature is set as 285 Kelvin. Again, make sure that your units are correct. Just click apply, and then you can see that the black arrows are pointing inwards, so we know this is an inlet boundary condition. Okay? And click OK. Now the only one that remains is the outlet boundary condition, which is here at the bottom. So what should we expect here? We should expect black arrows pointing outwards of our domain, okay? So again, right click, default domain, boundary, and we type out. There you go. We have our outlet boundary condition, the speed is 2, the temperature is the total temperature 300, and click apply. Is this correct? No, it is not. You can see that the black arrows are pointing inwards. So maybe you did this by accident, but then you can see, wait a minute, my arrows are not pointing outwards as I expected, they're pointing inwards. So this only means that the boundary that I just set up is an inlet boundary condition. So we go back to basic settings, and this is what we change. See, boundary type is set to inlets, we change to outlets, okay? We choose the relative pressure to be 0 Pascal, make sure the unit is correct, and click apply. So now we see the black arrows are pointing outwards, okay? In other lectures we're gonna use other boundary conditions, but just so as you can see, for example, the opening boundary condition, which is a boundary condition that allows flux to go outwards and inwards. So what we have is basically this. Let's choose a random temperature here. See? We have now this blue arrow that are pointing inwards and outwards of our domain, which showcases that this is an opening boundary condition. This allows flow to go in and out of this phase. Okay? This would be an interesting boundary condition if we had a very turbulent flux near this phase right here. Okay? For example, if we were dealing with a river, for example, and then we're monitoring a phase of the river, then we probably would be using an opening boundary condition instead of an outlet. But in our case, we're using an outlet. So just make sure that the relative pressure is set to 0, click apply, make sure the arrows are pointing outwards, and we would be okay. Okay? So this is the boundary conditions already properly set up. Okay, now save the file, save your model, your simulation. Okay, and now we're gonna select our solver control. Remember when we chose the different physical time scale back in lecture 2? Now we're gonna do the same here. So go to solver control. Now we're gonna use the high resolution active action scheme. Remember in the lecture 2 we used the upwind active action scheme. Now we're gonna use the high resolution because it is more accurate than the upwind scheme. But because of this we usually require a smaller time step to use this model. Okay? And you can also expect, if I remember correctly, our simulation took around a little bit over 30 iterations to be done. If I remember correctly, we can expect more iterations for this one to be done, just because we are using a more refined mesh, and especially the high resolution advection scheme. Okay, so we're gonna change max iterations here to 150. So we're giving the software more room to work with, more room to achieve convergence, and we're gonna change our time scale here. We're gonna change from auto time scale to physical time scale, and we're gonna choose 0.5. Okay, 0.5. There we go, 0.5 seconds. Make sure that the unit is correct, the unit in seconds. Okay, and this is what we're gonna choose for this simulation. So click apply and click OK. All right, now we can save the simulation because our setup is already done. As you notice, when you are more familiarized with the problem, your setup goes quicker, right? Goes much faster. This is because we already dealt with this problem, so we are already familiarized with it. Okay, and this is something that you can expect when you're working with your projects. You're the most familiarized person with your project. It's not your advisor, it's not another professor, it's you. So you can expect to know this type of detail without needing to look at a sheet or something else. Okay, so this process should go very fast as well. What's gonna take time is when you run the simulation and you see, okay, the results are not quite as I expected. Maybe you are comparing it to a physical experiment and your simulator results are not similar to the physical ones. So you need to go back to your setup, or maybe you're gonna need to go back to your geometry, maybe you're gonna need to go back to your mesh, and this process of going back and checking is where it takes time. Okay, but even still is faster than if you would do this in a physical environment. Can you imagine, like, okay, I need to test a bunch of stuff, so I'm gonna need to run a bunch of simulation, a bunch of experiments, and maybe even I'm gonna need to build different experiments to run something. So this is something that CFD has in its advantage. Okay, so we saved our simulation, now we're gonna run it. So click here, define run. I'm gonna leave it lecture 3, the point DAF5. I'm not gonna change this, so I'm gonna save. And now we have it open here, our define run, our solver manager, basically. Okay, so here we're not gonna change anything. What we're gonna do is we're gonna run our simulation here, and you can see that we didn't change the convergence criteria. So as soon as all of our curves, the RMS, PMAS, RMS UMOM, the VMOM, and the WMOM, as soon as they go below this line right here, 10 to the minus 4, the simulation is gonna stop, and it's gonna tell us that, okay, your data has achieved your convergence criteria, which was 10 to the minus 4. Okay, and you can already see that it takes much more time steps, much more iterations than the one we did in lecture 2, because we're not using the upwind advection scheme anymore. We're using high resolution one, and our mesh is more refined. Okay, so there we go, we have our solution converged. And again, this is gonna be the first image that I want from you guys for this lecture. You're gonna print screen this one and you're gonna send it to me so that I know that you have run the simulation and that you didn't simply use the results file. Okay, so this is the first file that I want you to send it to me. Okay, so you can close this, and now we're gonna run our CFD posts results. So we can go here, you can even close this one, save and quit, and you can open the CFD post. Okay, so now we're going to load our results right here. Okay, so the results that you're going to load is this one. Actually, it's not going to be this one. It's going to be the one that you named. I don't know how the name that you guys are going to put in your results file, but this is the one that you're going to want to open. Okay, it's going to be the name that you put underline 001. Okay, so this is the file that I want you to open. Okay, there we go. So now we have our domain right here. Remember, you can choose how you see this just by changing the wireframe. Okay, so you can change the wireframe here, double click wireframe, and maybe like change it to 30 from 30 to 15, and you can better see, for example, the inlet and outlet pipes. You can even change further to 10, and you can get a little bit more detail. Okay, but 15 or 10, both is fine. Okay, so now let's take a look at some of our results. Okay, let's create a slice plane like we did before, like we did in our previous lecture. So let's create a plane. How you do this? I'm sorry, I think I was going too fast. You click here in location, and then you open plane. The name doesn't really matter, so I'm gonna leave it plane 1. Okay, now we need to decide where our plane is gonna be. I'm gonna change. You can actually see, like, if you put 0 and click apply, the plane is at the bottom of our tank right here. So you can see, for example, okay, so here's at the bottom. If I go all the way to the right in the slider, it's gonna be up top, so it's gonna be 2. And maybe you want right in the middle. So what you choose? You choose 1. Okay, you click apply, and then you can see the slice plane passing right through the middle of the upper part of our tank. Okay, so let's go here, right click, predefine camera, isometric view, Z up. There you go. This is gonna be basically the camera that we want to use for this lecture, the visualization of the results. Okay, but let's see the difference in mesh. Okay, and how we do this? We go here to render, we don't tag show faces, and we check show mesh lines, and then we're gonna see something like this. Now I want you to go back and see this. Remember that we did the same image in lecture 2? Remember that we did this exact same image in lecture 2 to see our mesh. And now what I want you to do as the second image that I want you guys to send me is basically this. I want you guys to go back to lecture 2, and you're gonna send me this image right here. How you do this? You can go here, you can save it wherever you want with whatever name, change the scale to 500 so you get a better resolution of your image, and I want you to send me this picture here, both from lecture 2 with the coarser mesh and from this lecture right now with the refined mesh. You're gonna see a difference, especially in the border. You're gonna see that in the coarser mesh you don't have these well organized elements in the border of the tank. So this is what I want you guys to take notice. Like this better organized elements in the border give us better results at the regions near the walls. If you guys remember from fluid mechanics, as the fluid gets closer and closer to the wall, its velocity tends to go to zero due to the no slip condition, where the fluid is going to assume the same velocity as the wall. Okay, so when the wall touches when the fluid touches the wall, its velocity is going to be zero. So you need to have a better the quality of your elements near the wall needs to be better than the elements in the interior of it. Okay, so this is where you're gonna see a difference between the meshes. Okay, so to remember, you guys, I want you to go back to lecture 2 and send me this mesh image right here, and then you're gonna go here in this simulation of lecture 3, and you're gonna send me this one as well, so I can compare both of your meshes and know that you did this. Okay, so this is the second image that you're gonna send me. Okay, the image of the coarser mesh and the image of the more refined one. Okay, so let's continue. Now let's color our slice pane. So let's go back here to render, show faces. Now let's change the color from constant to variable, and the variable that we're gonna choose is gonna be temperature. Okay, so let's click apply. Let's change the camera again. There you go. So now you can see the differences in temperature from the hotter inlet pipe and the colder inlet pipe. Okay, so what I'm gonna do here is I'm gonna show you a difference between this image right here and the one from our previous simulation. Okay, so let's do something here. Uncheck plane, and let's create a contour plane. So click here in contour, the name doesn't matter. In location, you change default domain default to plane 1, change the variable from pressure to temperature, and select 100 number of contours. Okay, and now you have this file, this image right here. Okay, now let me see if I have it saved, the other image here. So here you go, guys. This image I generated using our previous the mesh from lecture 2, and this is the one that I had just showed you guys. So what you can already tell is that both hotter and colder water in the more coarser mesh, they take hold of the whole pipe right here. As you can see, like they enter and they go around maybe a fourth of the diameter. Okay, and the same goes to the cold water one. Okay, you can see that they basically, like right here, they already start to dim to the more clearer blue or clearer yellow. But if you look here, you can see that both hotter and colder water, they go much more deep inside our tank. You can see here that they go like almost to the middle of our tank here. And this is because we have better elements at the borders of our tank. So we are better capturing the difference in temperature here than we are capturing here. Okay, we're losing some information here because the elements in this mesh are not capable to capture the transition of temperature. Okay, so this is something that you can already tell is better in the refined mesh one, and you can tell that is better because we know what to expect from our problem. Okay, we should expect that that the temperature wouldn't be so abruptly changed here in the tank, because the inlets are so far apart that the temperature should not be changing so quickly like it is here. Okay, it should be more slowed. The difference in temperature should be slowed down, and as it goes towards the inside of the tank, we have a more uniform temperature, and you can see that this happens here and not here. Like, if you take a look, you can almost see that yin and yang symbol in the coarser mesh here. You can see like this big blue zone and this big yellow zone and a very small green zone right here, which is not something that we should expect, because for the size of this tank, the inlet speed is not that high, so it shouldn't be, there shouldn't be a so dramatic, there shouldn't be I'm sorry, I'm struggling to find the correct English word here, but it shouldn't be this difference in temperature from the two sides. Okay, the temperature, especially in the middle, should be more uniform, and this is something that we can see. I'm gonna make it bigger here, and you can see better in the more refined mesh. Okay, so this is something that you can already tell that only by changing the advection scheme and the mesh quality, we already achieved much better results. Okay, so sometimes this is something that you're gonna have to keep in mind, like maybe my inlet, my boundary conditions are correct, maybe I measured them correctly, or I extracted them from literature correctly, and something that I need to change is gonna be either geometry or mesh, or something related to your solver controls. Okay, so this is something that you need to keep in mind. And also, this is something that I want you guys to be the third image that you guys send me. Okay, I want you to show me a side-by-side comparison of your contour geometry, contour temperature, both from the coarser mesh from lecture 2 and this one from lecture 3. Okay, so the third image is a side-by-side comparison of this slice contour from lecture 2 and lecture 1. Okay guys, so this is it. I'm gonna remember the files that you need to send me, which are basically the one that shows your curves converging all the way back in solver, in the solver control. The second image is a side-by-side comparison of the meshes. Remember, I want a side-by-side comparison of selected. I want a side-by-side comparison of this. So I want you guys to send me the one from lecture 2 side by side with the one from this lecture. Okay, so you guys can see the difference in meshes between them, and the one that I just showed you, right? I want you to see a side-by-side comparison of this image and the one from lecture 2. Okay, so 3 more files, 3 more images that I want you guys to send me. Okay, so that's it guys. Hope you guys understood this lecture. If you had any doubts, you can send me via email. So thank you guys very much, and take care.